Hi. So now what we're going to do is we are going to talk about how do we prove that something is invalid. And I will say that in general, it's a lot easier to show that something is wrong than to prove that it's right. And what I'm going to do is I'm going to show you one way of proving that something is invalid, and that's called using a counterexample. So I'm going to use an example for a counterexample from my geometry class. And so we're going to talk about two triangles here. And I'm going to reference Proposition 8 from Book 1 of Euclid's Elements. And that proposition states that if you have two triangles, as I have here, and we know that the blue side is equal to the blue side, and that the red side is equal to the red side, and that the purple side is equal to the purple side. Well, that proposition states that if that's the case, then that means that their angles are the same as well. And so specifically what's being said here is that the angle that's in between the purple and the blue here has to be equal to the angle that's in between the purple and the blue there. The angle that's in between the purple and the red has to be equal to the corresponding one over there. And then lastly, this last angle obviously has to be equal to that angle over there. So that's the proposition, and it's true. And in geometry, we proved that. However, when we were going through this as a class with my geometry students last year, we were wondering, okay, so we know that if the sides are equal to the sides, that means the angles will be equal as well. Does that mean that if you have two triangles and the angles are equal, does that mean that their sides will also be equal to each other? So this is called the converse. It's flipping something around to be the other way. Here we know that the sides being equal led to the angles being equal. Is it also true that if the angles are equal, the sides are equal? And at first glance, it would seem like, yeah, that makes sense. That is true. But all it takes is for me to show you one example for when that's not true. And then you'll know that that entire conjecture that I just said is false. Okay? So if I can show you one counterexample, if I can show you one situation where you have two triangles where the angles are equal and the sides are not equal, then that is enough to prove that this converse theorem that I'm wondering about, I'm going to prove that it's invalid. Okay? So what I'm going to do is I am going to show you two triangles where the angles are equal. And it's really easy to do that. You might have heard of similar triangles or similar polygons. And what similar means is it's the same basic shape, but it's just either been stretched out or it's been shrunk down. And so what I'm going to do is I'm going to take this original triangle that I started out with, and I am going to double the lengths of each of the sides. And so purple is going to be twice as long as it was before. Blue is going to be twice as long. And red is also going to be twice as long. And we know that when you have similar shapes, it doesn't change their angles. The relationships of the angles remain the same. And so what I know for sure is that this angle is the same as it was over here. And so is this one. It's the same as that one. And then the purple one down here is also the same. So here is what I have. I have two triangles where their corresponding angles are equal to each other. Does that necessarily mean that the sides will also be equal? Obviously not. So this one example that I showed is a counterexample. So when I was wondering, hey, if you have two triangles and the angles are the same, does that mean that the sides are the same too? Definitely not. All it took was this one example to show that it's not true. It doesn't matter if I can ever conjure up a time when that is true. All it takes is just one counterexample to prove that that is invalid. Okay, so this is an example from geometry. What I'm going to do now is I'm going to take a look at your worksheet And this is the one that says syllogism review and hypothetical practice. And on this assignment, I asked you to draw a diagram. If it's valid, just write that it's valid and move on. However, if it's invalid, I asked you to prove it with a counterexample. And I'm going to walk you through what a counterexample looks like with a syllogism. Okay? And so we're going to do number one together. And we're going to write down the abbreviated form and make sure it's in the right order. So remember that some of your conclusions might be out of place. We want it to always look like premise, premise, conclusion. And so if it's not in that order when you're abbreviating it, you need to make sure you put it in that order. So number one from your homework says, some wild animals are protected species, so some grizzly bears are protected, since all grizzly bears are wild animals. I need to figure out what my conclusion is. And remember that since is one of your premise words. It's like a reason why. And so is the thing that you're trying to say. So here is my abbreviated form of number one. I know for sure that so some grizzly bears are protected species. I know that that is my conclusion. I'm actually just going to write that first to get out of the way. So therefore, some grizzly bears are protected. Okay, so there's my conclusion. Now I know I have two premises. I have one of them is some wild animals are protected, and the other one is all grizzly bears are wild animals. Now, in formal logic, there are some rules about like premises have to go in a specific spot. One of them is a major premise, one is a minor premise, and you have to get their terms in the right spot. For the purposes of drawing a diagram, that does not matter, so I don't really care for right now. I'm going to start with my first premise saying some wild animals are protected species. So some wild animals are protected. And then my second premise is where it says since all grizzly bears are wild animals. All grizzly bears are wild. Okay. And I'm just going to double check that I only have three nouns that I'm using here. I have wild animals and wild animals, protected species and protected species, and then grizzly bears and grizzly bears. Okay, so I'm good to go. So let's start by drawing a diagram. I'm going to draw my premise that some wild animals are protected species. So here is my protected species category. And I need to show that some of the wild animals are in that category. So I'm going to draw this. I don't know how many of the wild animals are in that category, so I am not going to close the stuff out here. All I know is that some of the wild animals are in there, and that'll be this stuff right here. All right, my second premise says that all grizzly bears are wild animals. And so you can see here, there's going to be a possibility. I don't know where I'm going to put my grizzly bears. Am I going to put my grizzly bears right here? Am I going to put them inside of there? I should be able to put it wherever, and it should always work if it's valid. So for right now, I'm just going to go ahead and put the grizzly bears right here. The G for grizzlies. Okay. So there's my premises that I drew. Now I'm wondering, does my conclusion have to happen? Does it have to be the case that some grizzly bears are protected? And from the way that I drew it right here, it definitely does not have to be the case. My conclusion does not have to happen. I very easily drew grizzly bears that didn't have anything to do with the protected species. So since my conclusion did not have to happen, I am going to say that this is invalid. Okay. However, drawing a picture is not always the best way to prove that something's invalid. In order to prove that, I am going to use a counterexample. And remember that a counterexample is just showing one situation where the thing that you set up doesn't have to happen that way. So here's how we do a counterexample. We're going to take the same form of the argument from up here, and we're going to rewrite it using easier things to think about, okay? And I did this a couple of videos ago. I'm going to take the same form and use different words. And so my wild animals, since it goes here and here, I need to make sure I'm putting whatever I replace that with needs to go in the same places. The protected species was here and here. And then the grizzly bears is here and here. Now, you might recall from the last time I did this, the example that I gave you with the dogs and the poodles was this exact same form of argument. So you might guess that this is an invalid form of an argument. It doesn't matter what words go there. I actually just remember that it's invalid because I remember where I drew my triangles and my circles and my squares. So I'm going to rewrite this using the same form and making sure that I'm putting my same shapes there. So it started out with some blank are blank, and then all blank are blank. And then the last thing, the conclusion, was that some blank are blank. Okay. Now I need to make sure that whatever went right here where this red triangle was is the same one right there. And that everything matches up accordingly. Okay, so last time I used dogs. This time, why don't I use, I don't know, I'll just use mammals. All right, so I am going to say that some animals are mammals. Some animals are mammals. Okay, now these are very broad categories of things, so I should be able to do this pretty easily. There are animals that are not mammals. Mammals are a specific kind of animal. So my statement that some animals are mammals is true. Okay, now remember that whatever I put here, I have to put there too. So if I put animals right here in my subject, it needs to be my predicate of my second one. So animals here, and then I need to make sure that where I put my green thing, my mammals, needs to go down here. Okay, so my last thing that I need to do is I need to figure out what word I'm going to put here that's going to be able to give me my counterexample. Now, what I'm looking for is I'm looking for one situation where this does not have to be the case, okay? And remember my example from the triangles. All I had to do was just show you one situation where you had two triangles with the same angles and their sides aren't the same. That's all it took was one. Okay, I could have drawn a million different ways that it didn't work. And I could have drawn lots of ways that it did work. But all I needed was just one situation where that conclusion did not have to happen. And so I need to think here, what's one word that I could use here where my conclusion does not have to be true, okay? So I need to think of a word where all of them are animals, but it's not true that some of them are mammals. Can you think of anything can you think of anything that is an animal that is not a mammal? Okay, can you think of anything that's an animal that's not a mammal? And I would say bird, right? Birds are not mammals. So this is the word that I'm going to choose. I'm going to say that all birds are animals, and that is true. And remember, since I had to have that blue square word right there, it needs to go right here in my conclusion. Now I'm going to fill it in right here. And this is what my argument says. It says all or some animals are mammals, all birds are animals. And both of these premises are true. Okay? Now, does my conclusion have to be true? Is my conclusion also true? Some birds are mammals. No, that's false. There are not birds that are mammals. I did what I needed to do because what I'm looking for is I'm looking for this conclusion statement to be false. I'm looking for a counterexample. I'm trying to show you that it's a ridiculous thing to think that some birds are mammals. It was really easy for us to see this with this situation right here. Just like when I showed you my geometry thing, it was really easy for me to show you I have a blown up version of a triangle and then a smaller one. The angles are the same. That doesn't mean that the sides are the same. Same thing here. I have an easy situation with animals and mammals and birds, and I'm able to show you that my conclusion is false. So that is a way of proving, using one counterexample, that your argument is indeed invalid. So when you're filling out this worksheet, if you got invalid when you were doing your diagrams, you need to come up with a counterexample. And if it helps you to put shapes or underline the terms with colors, that's great, whatever it takes, but make sure that you put things in the same places that they were up here. And you're looking to find a way where if your premises are true, your conclusion is not true. And that's going to prove it's invalid.